right, guys, this is part 2. We accidentally stopped the first video and didn't mean to. So this is actually part 2 of what we're doing. We're not quite done yet. We've got a couple more definitions. So these two are the really important definitions for this unit. And if you were going to be tested on this year, or any tests you might see on this next year, you really need to know the difference between a rational or an irrational number. So the definition of a rational number is any number that can be written as a ratio, and all that means is something that can be written as a fraction. There are so many examples of numbers that fall into this category. Most of our numbers are going to fall into this category. So when you have rational numbers, you can actually have a counting number like 10. How do you change a number like 10 into a fraction? You just stick a 1 under it. So I can write that as a fraction, therefore it's rational. You could also have a negative number. So if I gave you -5, can you write -5 as a fraction? Same thing. How could you write -5 as a fraction? You can stick a 1 under it. So it's all your positive numbers, all your negative numbers. You can write 0 as a fraction by putting a number under it. Can't have 0 in a denominator ever, but you can have 0 in a numerator, okay? You could have a square root of 25. What's the square root of 25 going to equal? 5. And can you write 5 as a fraction? You can by putting a 1 under it. You also are going to have your basic fraction, okay? So can I write 4/7 as a fraction? I can, because it's 4/7. It's already a fraction. You can have terminating decimals like 0.75. If you have 0.75, what you need to ask yourself is, can you write that as a fraction? And if you have 0.75 as a fraction, that simplifies or rewrites to 3/4 as a fraction. Okay, the last example, and this is where we kind of lose a lot of people. You can write a repeating fraction as a repeating decimal as a fraction. And I know it's been a while since we were together and we haven't seen those in a while. But remember, if you have a repeating decimal, the fraction for that would be 3, not over 10, but over 9. Remember, if it's a repeating fraction, for a repeating decimal, your denominator is going to be 9 or 99 or 999. So anything you can write as a fraction is considered a rational number. Positive, negative, terminating decimals, repeating decimals, all of that can be written. Okay, irrational numbers. So if most things can be written as rational, what does it mean to be irrational? To be irrational means a number that cannot be written as a fraction. So the basic first example of that is pi. Now, most of you know that pi, you're like, well, that's 3.14. It is, but that's not the actual number for pi. The number for pi is infinite. It rambles on and on and on and on and on forever with no repeating pattern, and it never terminates. So you can't write that as a fraction because you don't have anything to go on with the denominator. The other example of an irrational number would be like the square root of 20. 20 is not a perfect square. So if you punched in your calculator the square root of 20, you would get something that I call a rambling decimal. It doesn't terminate and it doesn't repeat. It just goes on and on and on forever in a rambling pattern, and you can't write that as a fraction. So the main two categories for irrational numbers are going to be pi and a non-perfect square root. So some examples again of non-perfect square roots would be like the square root of 5, the square root of 10, the square root of 50, the square root of 20. Any of those, they're not a perfect square root. You can't simplify that to a whole number. And that's the one that tricks a lot of people. They forget that that's irrational. You can't write that as a fraction. Okay. This number 6 is not actually on the notes, but it's really simple. Real numbers are just all of the rational numbers and irrational numbers. So everything that we've talked about is considered a real number. You don't get into things that aren't real numbers until Math 2 or Math 3. So every single number falls into this category, whether it's a rational number or an irrational number. If you do go and look on the notes on Canvas, there's going to be this bullseye figure, and I can talk more about that on Zoom. So if you don't understand what that looks like, then that's what I'll talk about tomorrow. So if you wanted to take a screenshot of this, I'll stop it for a second, or again, you can always go into Canvas and print out those notes. Okay, so I hope that you guys will join us for our Zoom meeting tomorrow. If you're in block 2, that's going to start at 12, and if you're at block 1, that's going to start at 1. I'm sorry. If you're in block 3, that's going to start at 1. Check your emails for invitations, and I hope to see you then. Bye.